By the end of this lesson, students will be able to correctly pronounce sine, cosine, and tangent, identify opposite and adjacent sides of acute angles, identify the hypotenuse of a right triangle, and correctly write ratios for sine, cosine, and tangent of an angle, and to use trig functions to solve applications. The three trigonometric functions we're looking at today are called sine, cosine, and tangent. Sine is pronounced sine. Cosine is pronounced cosine. Tangent is pronounced tangent. The abbreviations for sine, cosine, and tangent are SIN, COS, and TAN. The Greek symbol in the upper right corner is pronounced theta. It's a variable that represents an unknown angle. The box in the lower right corner of the triangle indicates that this is a right triangle. A right triangle has an angle which measures 90 degrees. The side across from the right angle is called the hypotenuse. Let's look at angle B. Across from angle B, we have the side that is opposite angle B. So the side that is across from an angle is called its opposite. This side is also adjacent to angle A. Across from angle A, we have the side that is opposite angle A. We also have the side that is adjacent to angle B. Let's look at the trig functions. Theta is an angle within the right triangle. Sine of theta is defined as the side that is opposite theta divided by the hypotenuse. This is the side that is opposite theta. This is the hypotenuse. Sine of theta equals the side that is opposite theta divided by the hypotenuse. Cosine of theta is defined as the side that's adjacent to theta divided by the hypotenuse. This is the side that is adjacent to theta. This, again, is the hypotenuse. And we know that it's a hypotenuse because it's across from the right angle. Tangent of theta is defined as the side that is opposite theta divided by the side that is adjacent to theta. This, again, is the side that is opposite to theta. This is the side that is adjacent to theta. Remember the mnemonic device SOHCAHTOA. Sine of theta is equal to the side opposite theta divided by hypotenuse. Cosine of theta is equal to the side adjacent to theta divided by the hypotenuse. And tangent of theta is equal to the side opposite theta divided by the adjacent side to theta. Write the sine, the cosine, and the tangent of angle A as fractions. The sine of angle A is defined as the side opposite angle A divided by the hypotenuse. The side opposite angle A measures at 9. The hypotenuse measures at 10.8 units. Therefore, sine of angle A is 9 divided by 10.8. The cosine of angle A is defined as the side adjacent to angle A divided by the hypotenuse. The side adjacent to angle A measures at 6 units, and the hypotenuse again is 10.8. Therefore, the cosine of angle A is equal to 6 divided by 10.8. The tangent of angle A is defined as the side opposite angle A divided by the side adjacent to angle A. The side opposite angle A again is 9, and the side adjacent to angle A again is 6. Therefore, tangent of angle A is equal to 9 divided by 6, which reduces into the ratio 3:2. Find the sine, the cosine, and the tangent of angle A. Sine of angle A is defined as the side opposite angle A divided by the hypotenuse. In this triangle, the side opposite angle A measures at 8.2 units, and the hypotenuse is 24.5 units. Therefore, sine of angle A is equal to 8.2 divided by 24.5. The cosine of angle A is defined as the side adjacent to angle A divided by the hypotenuse. The side adjacent to angle A is 23.1, and the hypotenuse, again, is 24.5. Therefore, cosine of angle A is equal to 23.1 divided by 24.5. The tangent of angle A is defined as the side opposite angle A divided by the side adjacent to angle A. The side opposite angle A, again, is 8.2, and the side adjacent to angle A, again, is 23.1. Therefore, the tangent of angle A is equal to 8.2 divided by 23.1. Figure out which ratio to use. Find x and round to the nearest tenth. Here we have a right triangle. One of the measurements is 55 degrees. The side across from 55 degrees is x. Therefore, x represents the opposite side. The side adjacent to the 55 degrees is 20 meters. Therefore, the trig function which relates the opposite side with an adjacent side to an angle is tangent. So tangent of 55 is equal to x divided by 20. The rest becomes algebra. We're going to multiply both sides by 20, so we're left with 20 times tangent of 55 equals x. To find the final answer, we're going to plug this into our calculator. 20 tan 55 close parentheses, then hit enter. So you're to type into your calculator 20 tangent 55 close parentheses. X is approximately 28.6 meters. Find the missing side, round to the nearest tenth. Here we have a right triangle in which one of the angles is equal to 72 degrees. Across from the 72 degrees, we have a side which measures at 80 feet. Adjacent to the 72 degrees, we have a side that is represented by x. The trig function which combines an opposite side with the adjacent side of an angle is tangent. Therefore, the tangent of 72 degrees is equal to 80 divided by x. The rest becomes algebra. We're going to multiply both sides by x, so we're left with x times tangent of 72 equals 80. Next, we have to divide both sides by tangent of 72 degrees. So x is equal to 80 divided by tangent of 72. In your calculator, you're to type 80 divided by parentheses tangent 7 2 close parentheses, and then equals. X is approximately 26 feet. A boy flying a kite lets out 300 feet of string, which makes an angle of 38 degrees with the ground. Assuming that the string is straight, how high above the ground is the kite? The first step is to draw a triangle, a right triangle. We're told that 300 feet of string makes an angle. So which part of the triangle represents the string? The hypotenuse. The string makes an angle with the ground, so it's the hypotenuse which represents the string. We're also told that the ground is involved, so the base of the right angle is the ground. Next, we're asked to find how high above the ground is the kite. So this part of the triangle represents the height above the ground. The next step is to label the triangle with the values. So we're told that the string is 300 feet long. Next, we're told that the ground and the string make an angle of 38 degrees. And we're asked to find the height above the ground. So we're going to let x represent the height above the ground. Across from the angle of 38 degrees, we have x. So x represents the opposite side. We're given the value of the string, which is 300 feet, and that represents the hypotenuse. So the trig function that relates hypotenuse and opposite sides is the sine function. Therefore, sine of 38 degrees is equal to x divided by 300. The rest becomes algebra. We're going to multiply both sides by 300. The 300s on the right cancel out because we're multiplying and dividing by 300. So we're left with 300 times sine of 38 degrees is equal to x. X is approximately 184.7 feet. A ladder leaning against the wall makes an angle of 74 degrees with the ground. If the foot of the ladder is 6.5 feet from the wall, how high on the wall is the ladder? The first step is to draw a right triangle. The next step is to label the sides of the triangle. We're first told that a ladder is leaning against a wall. The ladder is represented by the hypotenuse. So the hypotenuse represents the ladder. Next, we're told that the foot of the ladder is 6.5 feet from the wall. Therefore, the base of the triangle represents the distance between the foot of the wall and the ladder. The next thing that we're told or asked is how high on the wall is the ladder. So the left part of the triangle represents the wall, or the height of the wall. The next step is to label the triangle with the values. The first value that we're given is the 74 degrees between the ground and the angle of the ground and the ladder, the angle that the ground and the ladder makes, which is 74 degrees. The next value that we're given is a 6.5 feet distance or foot distance between the foot of the ladder and the wall. So we label that. Finally, we're asked how high on the wall is the ladder. So the left part of the triangle is going to represent that unknown value. So we're going to let x represent the height of the wall. The height of the wall is opposite the angle that the ladder makes with the ground. The distance between the foot of the ladder and the wall is adjacent to the angle made between the ladder and the ground. Therefore, the trig function which relates the opposite side with the adjacent side is tangent. So tangent of 74 is equal to x divided by 6.5. The rest becomes algebra. We're going to multiply both sides by 6.5. The 6.5 on the right side cancels out with the 6.5 that's being divided. So 6.5 times 6.5 divided by 6.5 is equal to 1. So on the right side, we're left with just x. So 6.5 times tangent of 74 is equal to x. X is approximately 22.7 feet. An airplane climbs at an angle of 11 degrees with the ground. Find the ground distance it has traveled when it has attained an altitude of 400 feet. Step 1, draw a right triangle. Step 2, label the triangle. One of the first things that we're told is that there's a ground distance. So the bottom part of the triangle is going to represent the ground distance. So the base of the triangle represents the ground distance. We're told that the plane has reached an altitude. So the left part of the triangle, which is vertical, is going to represent the altitude. The final part of the triangle, which is the hypotenuse, is going to be the distance between the current and initial positions of the plane. So the plane took off from the lower part of the hypotenuse and is now at the higher part of the hypotenuse. The next step is to label the triangle with the values. The angle between the ground and the flight of the plane, or the point of takeoff, is 11 degrees. So we label that. The next value that we're given is the altitude of the plane, and we're told that it's 400 feet. So we label that. Finally, we're asked to find the ground distance. So we're going to use a variable to represent that unknown ground distance. The altitude is opposite the angle, and the ground distance is adjacent to the angle. Therefore, we're going to use tangent, which connects opposite side with adjacent side. So tangent of 11 degrees is equal to 400 divided by x. The rest becomes algebra. The next step is to multiply both sides by x. X times tangent of 11 degrees is equal to 400 divided by x times x. The x's on the right side cancel out. So we're left with x times tangent of 11 degrees is equal to 400. The next step is to divide both sides by tangent of 11 degrees. X times tangent of 11 degrees divided by tangent of 11 degrees is equal to 400 divided by tangent of 11 degrees. Therefore, x equals 400 divided by tangent of 11 degrees. X is approximately 2,057.8 feet. A wire attached to the top of a pole reaches a stake in the ground 20 feet from the foot of the pole and makes an angle of 58 degrees with the ground. Find the length of the wire. Step 1, draw a right triangle. Step 2, label the triangle. The first thing that we're told is that there's a wire attached. So the hypotenuse represents the wire. The wire is attached to the top of a pole which reaches a stake in the ground. That's how we know that the wire is represented by the hypotenuse of the triangle. The next thing that we're told is that there's a stake in the ground 20 feet away from the foot of the pole. Therefore, the distance of the length of the base of the triangle is going to be represented by the distance between the stake and the foot of the pole. Finally, the last side of the triangle is represented by the pole. Next, we label our values. We're told that there's an angle between the wire and the ground of 58 degrees. So we label that. We're also told that the distance between the stake and the foot of the pole is 20 feet. So we labeled that. Finally, we're asked to find the length of the wire. We're going to let X represent the length of the wire. The distance between the stake and the foot of the pole, which is 20 feet, is adjacent to the angle that's made between the wire and the ground. The wire is represented by the hypotenuse of this triangle. The trig function, which relates adjacent sides with the hypotenuse, is cosine. So cosine of 58 degrees is equal to 20 divided by x. The rest becomes algebra. We multiply both sides by x. X times cosine of 58 degrees is equal to 20 divided by x times x. The x's on the right side cancel out. So we're left with x times cosine of 58 degrees is equal to 20. Next, we're going to divide both sides by cosine of 58 degrees. So x times cosine of 58 degrees divided by cosine of 58 degrees is equal to 20 divided by cosine of 58 degrees. The cosine of 58 degrees on the left side cancel out. So we're left with x equals 20 divided by cosine of 58 degrees. X is approximately 37.7 feet. Students should now be able to correctly pronounce sine, cosine, and tangent, identify opposite and adjacent sides of acute angles, identify the hypotenuse of a right triangle, correctly write ratios for sine, cosine, and tangent of an angle, and to use trig functions to solve applications.